All right, so today we're taking notes on the parallel and perpendicular lines, and so your notes will look like this. Okay, so first we're going to start with the definition of parallel lines. So parallel lines, they have this symbol, which are two lines that are going, they will never intersect, they'll never cross each other in the same plane. So they have the same slope and different y-intercepts. So as you look here in this example, these two, this one goes up 3 over 2, up 3 over 2. And if you look over here, 3, 2. So that goes up 3 over 2, up 3 over 2, up 3 over 2. So they are going to have the exact same slope. So if you extended this out forever, they will never, ever touch each other. Both their slopes equal 3 divided by 2. So when you look at this practice, we'll get to perpendicular lines here in a second, but when you get to this practice, what is the slope of a line that is parallel to the given line? The given line is y equals 3x minus 1. So because this is written in slope-intercept form, y equals mx plus b, 3 is our slope. So our slope for this given line would be 3. In this problem, y equals negative 2x minus 4. Again, it's written in slope-intercept form. Negative 2 is our slope. So the slope of a parallel line is also negative 2. Here, in problem number 3, it's given to us in standard form, not slope-intercept form, so we need to convert this. So the first thing we do is we move the 3x over, and when we cross the line, we change the sign. So this is 2y equals, instead of positive 3x, it's now negative 3x. This is still plus 3. And my second step is to divide by 2. So this becomes, I'm going to write it above here, y equals negative 3 divided by 2x plus 3 divided by 2. So my slope is 3 divided by 2. So the slope that's parallel is also negative 3 divided by 2. In this problem, number 4, it gives us x plus 2y equals 6, which again, this means it's in standard form and is not slope-intercept form, so I need to convert it. So I'm going to go ahead and move the x to the other side. And when it crosses the line, it changes the sign. So this is 2y equals negative x plus 6. In order to get y by itself, I divide by 2. And I'm left with y equals negative 1/2 x plus 3. So my slope here is negative 1/2. So remember, with parallel lines, my slope will always match the original line's slope. Now let's talk about perpendicular lines, because perpendicular lines, there's a little bit more work. So perpendicular lines, they have this symbol because they intersect. And when they intersect and when they cross each other, they form 90-degree angles, right angles. So their slopes will be opposite. It'll be the opposite signs. And also another term known as a reciprocal. So what a reciprocal means in math terms is it takes, I'm going to go ahead and use A over B. It takes a fraction and it flips it. So it becomes B over A. And again, it's opposite signs. So if this was positive, this becomes negative. So here's an example This one stretches from 5. Ooh, looks like it crosses right down there. So 1, 2, 3, 4, 5, 6 over 2. So it looks like the slope is -3, down 3 over 1, down 3 over 1, down 3 over 1. So this slope right here for A slope is -3. And B slope, the first thing that you'll notice is it's positive. It's going up. But it's not going up as fast. It's going up 1 over 3. So B slope is up 1 over 3. And again, it's positive, not negative. So when they cross, they form a 90-degree angle. So looking at your work down here, what we do is we take this to get the perpendicular slope. We have our original slope was m equals 3. We're going to put it over 1. If it's ever given as a whole number, we're going to put it over 1. We're then going to flip it. So this will become 1 over 3. And this was originally positive, so now it's negative. So the slope of what is the slope of perpendicular of the given line? The perpendicular slope of this is -1/3. And all you would have to do is you could graph this, and you could graph y equals -1/3 x. And when they cross, it should look like this, where it's making a 90-degree angle. You can turn your Chromebook or turn your head and notice that it's a 90-degree angle. If it's anything besides this, if it's -3, if it's 1/3, it's not going to show this as a 90-degree angle. So when in doubt, graph it out. Here, I'm given y equals -2x minus 4. So for my slope of perpendicular, my original slope starts off at -2. Because it's not written as a fraction, I make it a fraction over 1. I put it over 1 because -2 divided by 1 is still -2. I flip this around. This becomes 1 over 2. And instead of negative, it's now a positive. So my new slope is 1/2. And again, you can graph this, y equals -2x minus 4, and graph this, y equals 1/2 x, and see how they look. And when they cross, they should make a 90-degree angle. I can't show this on the video because on the video, I only have the camera. So here, this is why we like fractions and we like leaving fractions in graphing, because here my slope is 3 over 2. So it's already written as, or -3 over 2. It's already written as a fraction. So I just flip this around and it becomes 2 over 3. And instead of negative, it's positive. I just put boxes around my answers. Here, my slope is -1/2. So -1/2 to start. I flip it around, 2 over 1. And instead of negative, it's now positive. And 2 divided by 1 is just 2. Here, it says the steps to writing equations in parallel and perpendicular lines. First, identify the slope, identify the new slope, and then you'll want to identify a point that it passes through and substitute it in for point slope formula. So remember, parallel lines have the same slope. Remember, perpendicular has opposite reciprocals. So oftentimes we're given these points of write an equation of a line in point slope form that passes through this point, k, 1, -2, and it's parallel to this. So there you have a lot of things going on here. First thing is we're identifying that it's parallel. So therefore, it's going to be the same slope. So the first thing I need to do is I need to convert this into slope-intercept form so I know what the slope is. I have 2x plus y equals 1. So my one move I have to do, I move my 2x over. It crosses the line, so it changes the sign. So y equals negative 2x plus 1. So this identifies my slope piece. Boom, got that. It says it wants it in point slope form. This helps me out because in point slope form, I have y minus y1 equals m, x minus x1. So y minus equals x minus, and let's fill in these pieces. The first thing I'm going to fill in is my slope. My slope is negative 2. Boom, done. The second piece is my point. My x value is negative 1, or is 1, excuse me. So that goes there. My y value is negative 2. So that goes there. The one thing I have to simplify is this left side because I'm subtracting a negative turns to adding. So y plus 2 equals negative 2, x minus 1. This is a very common one to see. It says write an equation of a line in slope-intercept form that passes through the point K and is perpendicular to line C. So I need a line that kind of looks something like this, okay, that goes through this point, okay, and cuts through here. So let's go ahead and figure this out. The first thing I'm going to need, also it's in slope-intercept form. So I got to remember that. I'm going to write y equals mx plus b down here at the bottom because I'm going to need to remember that. Okay, let's start with this. I need to find the slope. Find the slope. So here, I'm going to use my y-intercept here. I don't have an x-intercept I can use, but I can use this point right here. It looks like it goes through in this point. It looks like it's pretty consistently going through these points. So I go down 1 over 3, down 1 over 3, down 1 over 3. So it looks like my slope is down 1 over 3. So it looks like my slope is negative 1/3. Okay, now I have this point K. So point K I'm going to write right underneath this. It looks like it's negative 3. Here, I'm going to change the colors so that way you can see what I'm talking about. I'm talking about point K here. Negative 3, positive 2. Okay, so I have the slope, this slope, slope C, and I have the point that it's going through. So what I will need to use is I'll need to use point slope form because that's what I'm given. Y minus y1 equals m, x minus x1. I'm going to write it with my blanks so then that way I know where I need to fill in pieces. Let's start with my points. That's negative 3. That's positive 2. Now when I look at my slope has to be perpendicular to my original slope. I don't want the same slope, so I don't want negative 1/3. So I have to flip this around. So this becomes 3 over 1. And instead of negative, it's now a positive. And 3 divided by 1 is just 3. So my slope here is 3. All right, so I have this written. I have it written in point slope form. Unfortunately, I need it in slope intercept form. So I'm still not out of the woods yet. So let's go ahead. Let's simplify this to get it to slope intercept. The first thing I want to do is eliminate my parentheses. X minus negative 3. That changes to x plus 3. So y minus 2 equals 3, x plus 3. I'm going to distribute this negative. Oh, excuse me, not that negative. I'm going to distribute that 3. Y minus 2 equals 3x plus 9. I'm going to add this 2. And I'm left with y equals 3x plus 11. So this is slope-intercept form. If I graph this, if I graph this, I could pull it up in Desmos. I would see, let's see, if I used 0 would be 11, -1 would be -3, so that's 8. -2 would be -6, and that would be 5. So -2, 5. -3 times 3 is 9. 11 minus 9 is 2, so it does go through that point. So it would be a line that's, the slope is 3, so left 1, down 3. Left 1, down 3. So it looks something like that. And that does look like it makes a 90-degree angle. So there you go. This is how we can graph parallel and perpendicular lines. And this one is by far the most complicated one that you could do.